I have another example of a Fermi problem. In this one, we're asked to estimate basically what volume of air you breathe over the course of a day. And then you're going to take that information in the ideal gas law, so that if the air is compressed by a factor of 180, what volume would it occupy, keeping it same number of moles, R is a constant, and then at the same temperature. Alright, so in this one, we're not starting with our beginning assumptions. We're going to develop them as we go. And the assumptions that I make may not be the ones that you make. That doesn't mean that yours are wrong or mine are right. These are reasonable assumptions to get an estimate, and there's not a unique answer or a unique way of doing that. The way that I thought about addressing this, so first I thought about how often do I breathe, and that is my estimate. About 15 breaths per minute. Obviously varies, but that seems like not a bad estimate. And then I know in terms of minutes, there are 24 times 60. So 1,440 minutes in a day. So that will let me get how many breaths I take in a day. Now, what's the volume of one breath? The way I thought of trying to estimate this was thinking about blowing up a balloon in just one breath. How much or how big of a balloon would I be able to blow up? And as an estimate, think of that balloon being equivalent to a sphere with a radius of about 4 centimeters. That seemed not too unreasonable, like the number of times it would take me to blow up a decent sized balloon and how much the balloon would blow up in one breath. So the volume of one breath, put that in as approximately the volume of a sphere, because that's easier to calculate than the actual volume of the geometric shape of a balloon. So 4 pi upon 3 r cubed, and estimated that radius to be about 4 centimeters, which is about 1.5 inches, and that works out to be 2.7 times 10 to the minus 4 cubic meters for one breath. So then the volume over a day I get from number of breaths in a day times the volume occupied by one breath. Basically take everything we have so far and multiply it together. 2.7 times 10 to the minus 4 cubic meters per breath. And take 15 breaths per minute. And 1.4 times 10 to the 3 minutes per day. And that works out to be 5.7 cubic meters per day. Sort of a volume of a pretty decent sized room there. Now for the second part of the question, if it is under a pressure of 180 atmospheres, then the volume is going to be correspondingly 180 times smaller. From our ideal gas law, and that is 3.2 times 10 to the minus 2 cubic meters, or 32 liters. Now, as a little check on this, the amount of volume in a scuba tank is about 3 liters, and that would be enough air for you to breathe for about 1/10 of a day. So this 32 liter number for the volume under a pressure of 180 atmospheres isn't too crazy of an answer. It seems like it's reasonable and within about 10% of what it would actually be. So just a little way to check your answer after you have something figured out and written down. Again, your approach to this problem could be very different. You could have a different estimate for how many times you breathe per minute. You could have some other way of trying to estimate the volume of a breath. I thought about it in terms of blowing up a balloon, because that's something I've done, and you could see what the volume of the object is. But however you come up with it, your estimate, then at the end go back and see if it makes sense. And based on what little I know about scuba diving, this isn't a crazy answer. So there you go.